Hi everyone, in this video we are going to talk about the trigonometric ratios. Trigonometric ratio is nothing but the ratio of any two sides of a right triangle. In this picture I have drawn a right triangle here, triangle ABC. The three vertices are A, B and C, and the opposite sides I have named them as lowercase a, B and C. C is nothing but the hypotenuse of this right triangle and the right angle is the angle C. And also I have denoted that angle B is theta. Let's assume that this angle, the measure of this angle is theta. Whether theta degree or radian doesn't really matter. We're going to assume that it's angle theta, right? So for this right triangle, how many sides we have? Obviously every triangle has three sides and I have noted them A, B, C. Now if we have to create ratios of any two sides of this triangle, how many ratios can we form? Let's think about it. So suppose I'm talking about ratios like, say for example, B to A, this ratio, right? So I can write it as B divided by A. That could be one ratio. B is to A, that could be one ratio. I could even say B is to C, that could be another ratio, B is to C, or even how about like C is to A, that could be another ratio. Similarly, we can say, okay, A is to B, that is another ratio, and then A is to C, another ratio, and also we can say C is to B would be another ratio. Now, could there be any other ratios using any two sides of this right triangle? I mean, as you can see, we have already used B over here two times. So the combination of B and A and then A and B, right? So I'm going to underline them like this. So B and A, for that combination, we get two ratios which are like this. B is to A or A is to B. Similarly, for B and C, we have B is to C, or even we have C is to B like this. And also, if you see the ratio between C and A, we can say C is to A or A is to C. Now, are there any other possible combinations? The answer is no. You can try it, but there are no other combinations than these six. Meaning, from the three sides, we can create three pairs and then we can use them in form of ratio, and also we can use their reciprocals, right? For example, B is to A and A is to B, they are reciprocal to each other. Similarly, B is to C or C is to B, they are also reciprocal to each other, and C is to A and A is to C, they are also reciprocal to each other. So those are the only six possible ratios that we can form using any two sides of the three sides of a right triangle. And that is why in trigonometry we have only six ratios, no more, no less. Exactly six trigonometric ratios, because we can create only six combination of ratios using any two sides of a right triangle. So now let's talk about these ratios and see if they have any specific name, right? So now we are going to talk about these ratios one by one, and actually they do have specific names. Now the first one that we are going to talk about is the ratio between the opposite side and the hypotenuse. Now let me also quickly talk about this opposite side and the adjacent side. The opposite side means is the side opposite to the angle B or theta, right? Whichever angle is theta, its opposite side, if you look at it, it's the angle theta is actually looking at that side, the side B, which is the AC side, right? So that is why it's called the opposite side, means it's the opposite side of angle theta. Similarly, the adjacent side, which is the side BC, this side is adjacent. Why? Because it is one of the rays that contain theta. That means that this side is adjacent. Now you can say, okay, then hypotenuse is also another adjacent. Yes, it is adjacent, but it has a specific name. We call it hypotenuse. That is why hypotenuse did not need another name. However, the side BC needed a name and we call it adjacent side. So now we know what is adjacent side. Well, it is the side that has theta angle next to it, and opposite side is the side that theta is looking at, right? Now we know what is an opposite side or what is an adjacent side, and for this particular triangle we are going to now create six different ratios, right? The first ratio that we are going to talk about is the ratio between the opposite side and the hypotenuse. So let me write it down. So the ratio between opposite side and hypotenuse will actually be B divided by C. B is to C, that ratio, and this ratio is called the sine of the angle theta. So this is called as the sine of the angle theta, and it's written as sin theta. In short, it is sin, but actual full name is sine. So this is called sine theta. So you can read it as sine theta. That means it's the sine of theta. Now sine of theta is nothing but the ratio of the opposite side of the theta angle and the hypotenuse of the right triangle, right? So this is the first of the ratios that we're going to learn. It is called the sine theta. Now let's look at the next ratio. The next ratio is the ratio between adjacent side and hypotenuse, and in this case it will be A divided by C. That's the ratio between the adjacent side and the hypotenuse, and this ratio is called cosine of theta. In abbreviation we write it as cos theta, like how I have written here, cos theta. That means it is the cosine of angle theta, right? So this is cosine theta. Now let's talk about the next ratio. So the third ratio is the ratio between the opposite side and the adjacent side, and that is B divided by A, B to A, B is to A, that ratio, and this ratio is called tan theta. It's the tangent of theta angle. So this is, in short, it is called tan theta. We write it as TAN, tan theta, and actual full name is tangent. It's the tangent of the angle theta, tan theta. Now also from here we can derive one quick little thing. From here you can see, well, if we say, okay, now can I divide both the numerator and the denominator by C? So if we say, okay, B divided by C in the numerator, and also in the denominator I am dividing A by C. From here you can see that B is to C, that ratio is nothing but sine theta. So can we say it as sine theta? So we can write that as sine theta, and then in the denominator you see A is to C ratio, A divided by C, that is nothing but cos theta. So we can write it as cos theta here. So tan theta is actually nothing but the ratio of sine theta and cos theta. So sine theta divided by cos theta, that is equal to tan theta. So that is also another important information we should remember. Now let's talk about the three other ratios. Well, the three other ratios are nothing but the opposite of these ratios, meaning the inverse of these ratios, right? When I say opposite, it's actually the inverse of these ratios, the reciprocal of these ratios. So let's quickly talk about them. Now again, we'll begin with the ratio between opposite side and hypotenuse, but this time it will be hypotenuse divided by opposite side. That will be the inverse of sine theta, right? So our next ratio would be hypotenuse divided by opposite side. So this is the first reciprocal ratio, which is hypotenuse divided by opposite side. In this particular example, it would be C divided by B, and this ratio is called the cosecant of theta. In abbreviation we write it as cosec theta. Actually it is cosecant. The name is cosecant. You can say cosecant or cosec, both are fine. So cosec theta, this ratio is called the cosec theta. And if you can see right here, this cosec theta is actually nothing but, can we do it like this? This C by B, I'm going to write the C by B as 1 over B by C. Can I bring the C down below right here? So this will be 1 over B by C. That means if you see, this is actually 1 over, what is B by C? B by C is nothing but sine theta. So you can say this is actually 1 divided by sine theta. So cosec theta is nothing but 1 by sine theta. Now let's talk about the fifth ratio here. The fifth ratio is the ratio between hypotenuse and the adjacent side, and this will be C divided by A, and this ratio is called the secant of theta. Secant, S-E-C-A-N-T, secant of theta. In abbreviation we write it as sec theta. So this is the ratio between hypotenuse and the adjacent side. Also this sec theta has a relationship with cos theta, because let's see right here, can we write it like this? The C divided by A, can I say, okay, if I divide both the numerator and the denominator by C, so the numerator becomes 1 and the denominator becomes A divided by C. If you look at it, this A divided by C, the A to C ratio is nothing but the cos theta. A divided by C is actually cos theta. So it is actually 1 divided by cos theta, and that is also another important relation that we need to remember, that sec theta is actually 1 by cos theta. Now let's talk about the very last ratio, which is the sixth ratio, and the sixth ratio is going to be like this. So our sixth ratio is the ratio between the adjacent side and the opposite side, and in this example it would be A divided by B, and this is called cot theta, the cotangent of the angle theta. In abbreviation it's written as cot theta. You can read it as cot theta. Now also this cot theta can be expressed as another ratio. So here if I divide both the numerator and the denominator by A, so numerator becomes 1 and the denominator becomes B divided by A. And if you see what is B divided by A, the ratio of B to A, that ratio is actually tan theta. Let me show you right here. We have the B to A ratio, that is nothing but the tan theta. So in this case we can say, okay, cot theta is actually 1 by tan theta, and that is also another important relation we need to remember between cot theta and tan theta, that cot theta is actually 1 over tan theta. Now all these reciprocal ratios, like the cosec theta is equal to 1 divided by sine theta, sec theta is equal to 1 divided by cos theta, and cot theta is equal to 1 divided by tan theta, these relationships are called reciprocal identities. These are nothing but the reciprocal identities. So let me quickly summarize this. So the reciprocal identities are like this, that cosec theta is equal to 1 by sin theta, and from there we can also say that sin theta is also equal to 1 by cosec theta because they are reciprocal to each other. Cosec theta and sin theta, they are reciprocal to each other, right? So cosec theta and sin theta, if you multiply them together, they will give you 1. That is why we call them, they are the reciprocal identities. So cosec theta will be 1 by sin theta. Similarly, sin theta will be 1 by cosec theta. Sec theta will be 1 by cos theta. Similarly, cos theta will be 1 by sec theta. And then cot theta will be 1 by tan theta. Similarly, tan theta will be 1 by cot theta. And also, if you look at this cot theta, we can also do a little bit of trick right here. So I'm going to do a little modification right here, that there will be another relationship that I can show you, that 1 by tan theta means we already have seen that tan theta is nothing but sin theta by cos theta. So I'm going to write it as sin theta divided by cos theta. And from here, the lowermost denominator will come to the top. So this will actually flip. This will become cos theta by sin theta. And that is also another important relationship between sin theta, cos theta and cot theta. Cot theta is actually cos theta by sin theta, whereas tan theta is actually sin theta by cos theta. So tan is sin by cos, whereas cot is cos by sin. I hope you now have a clear idea about the 6 trigonometric ratios and the reciprocal identities. I hope everything made sense. Also, there is an easy way to remember the trigonometric ratios. For example, we have sin theta is equal to opposite side by hypotenuse, that is sin theta, and then cos theta is adjacent side by hypotenuse, and then tan theta is opposite side by adjacent side. Now, if you look at this, so if we take the s from sin theta, so we are taking the s from sin theta, and we are saying that, hey, sin theta is actually the ratio of opposite side. So we are taking the O of the opposite side and the hypotenuse, the H of the hypotenuse, right? So using that, if we simply write it like this, we can say SOH, right? That is SOH. So it's like SOH. So that means sin theta is the ratio of opposite side divided by hypotenuse, meaning ratio of opposite side is to hypotenuse, that is sin theta. Similarly, for cos theta, can we do like this? Can we take the C of cos theta and then A for the adjacent side and then H of the hypotenuse? So from here, can we write it like this? We can say CAH. So this is like ka, CAH ka. So that's like so ka. And then for tan, let's do the similar thing. So for tan theta, I am taking the T from the tan theta and then O from the opposite side and A from the adjacent side. So that becomes TOA. So can we write it like TOA? So this is the rhyme you want to remember, that so ka toa. So now I am going to write it down below. So we can read it like so ka toa, SOH, so ka CAH, so ka toa, TOA. It's very easy to remember. You can practice a few times. So ka toa. So means sin theta is equal to the ratio of opposite side divided by hypotenuse. Similarly, cos theta is the ratio of adjacent side divided by hypotenuse, and tan theta is the ratio of opposite side divided by adjacent side. So this is one very nice little important rhyme that you can try and remember, and that will help you remember the first 3 ratios of trigonometric ratios, and then the other 3 are nothing but the reciprocal of this. So like cosec theta would be hypotenuse divided by opposite side. Similarly, sec theta would be hypotenuse divided by adjacent side, and cot theta will be adjacent side divided by opposite side. So if you can remember the first 3, the other 3 are nothing but the reciprocal of the first 3. So this is one nice little trick to remember the first 3 ratios of the trigonometric ratios. Thank you for watching. See you in the next video.